Hello and welcome to the third class of the Realist Astral Projection course. And I'm Peter Duchemin, and here is our situation. So we are we've had a look at the concept of an orally transmittable computer, the idea of the integral age, so the galactic integration. So this is a tool that's part of that movement. So it is not a um, ancient magical technique. It is a very future-oriented approach. And we talked about this magician's blockchain, the eBPS system, and we have talked about how it has essentially three functions: the universal knowledge index, the universal mnemotechnic imager, and the magical awareness projector. And I'm going to start here with this quote from Jonathan Allen. Jonathan Allen is an artist and a magician, and I believe he's the curator of the Warburg Institute, as well as the Magic Circle in London. And when I told him about this system, he said, "It sounds like you've reinvented the ruler." And we're going to see particularly how that's the case today. Um, so, yeah, here's our essential review. We're going to kind of start this class with just backtracking just a bit to reestablish the context, because I know that this is this is heady stuff, right? So just to kind of give us an idea of where we are, and we're talking about these EBPSs, emerp bracketed palatial systems, or if you want, abrapalices. It's a more kind of colloquial way of calling them. And what are they? They are discoverable mathematical cubic units that are essentially like magic squares, and they come out of the emerps. So the digitally mirrored primes. We don't use the term mirror prime because that is a different thing, but they are pairs of primes that have a mirror image on their, 13 and 31, right? For example, 17 and 71. And the emerps allow to build these palaces. And so we're using them as visualization frames, and we are interested in hosting a kind of an orally transmittable computer. What does that even mean? We're kind of in the process of figuring that out. It's essentially, what is the future of computer science once we're no longer seeing it as something that we have to use to build external machines? What if it's something that we can start to consider as a way of essentially establishing interior contemplative space? And so, yeah, we've talked this thing as a magician's blockchain, right? A discoverable series of palaces that everyone has access to the same palaces. They are essentially immutable because they're part of the number system. And of course, we've got these three functions. One is to store knowledge in kind of crystalline patterns. Um, One is to memorize positions. Now, the UMI is interesting because it's a universal mnemotechnic imager. We didn't really talk about that much last week because we mostly just talked about how we can use it to picture things at scale, so the planets or the solar system or what have you. But you can also use it for creating imaginary spaces. So whether this is a sort of it's sort of somewhere in between the UKI and the UMI without really being the MAP as such. It's really a function of the UMI, but imagine you build a little cabin and you built it in eBPS1 and you put things in it, and so got to the point where you could go in and navigate that space with a high degree of resolution and stability, and the concept of a of an, XYZ axis, a full depth immersive experience um, within that imaginal space. Because usually imaginal spaces feel more like a sort of dreamlike, two-dimensional experience. But this would be a fully kind of chartable three-dimensional experience, but it wouldn't correspond to a physical place. So there is this idea that the UMI can visualize physical spaces, but also it can visualize um, imaginal spaces. In some ways, it blurs the line between the two. And lastly is the MAP. And the MAP is what we're going to talk about for the most of this class, and it's really taking these two functions um, and using them simultaneously. So taking the function of the UMI, which allows you to picture spaces and environments, and the UKI, which allows you to see these flowering sort of crystalline resonance patterns, and then establishing those resonance patterns around particular locations. So um, this can this can be applied all over the map, so to speak. So we can do this in terms of astral projection. We can do it in terms of, I guess, what you could call remote viewing. We could do this both macrocosmically at the large scale and microcosmically at the small scale. So we can visualize atoms and we can visualize galaxies. And we can visualize places on Earth, and we can visualize places that don't physically exist. And we can build them with a high degree of fidelity. And we can essentially share them with people through conversation. If they're both adept at this system, it would not be that hard because you can give coordinates. You can give coordinates for particular things. So another person in conversation could reproduce the same visualization or the basic frame and skin it in a different way. So this is a set of techniques that are part of the galaxia-centric cultural shift. So I am contending that we are in the middle of a galaxia-centric cultural shift. And the last major cultural shift was the shift between the geocentric and the heliocentric. So that gave us the scientific revolution. Well, this is giving us something else, something beyond the scientific revolution, and it's integrating the science with also the body of myth and of magic. So there's a lot going on right now, and what we're looking at right now in the early stages is the contention with materialism, with the kind of legacy materialism of the scientific revolution. Just in that materialism as a philosophy seems to have um, kind of piggybacked itself on that scientific movement, particularly on Newton's contributions to that movement, and has kind of imputed this idea that the extended universe is a space to be a dead space to be exploited. Now, part of where we're going is to a return of the sacred in terms of feeling that the universal flesh, if you want to call it that, spatial extension, um, is sacred and alive. And so, as we get further and further into this galaxiocentric cultural shift, I believe that indigenous perspectives are going to become more and more the key. And so it's vital to foster those and to undo as much of the damage that has been done as possible, through the colonial period, because these are the perspectives that really will help us adapt to this enormous new context that we are now in, a path beyond technology, into maybe what we could call technicology. Um, all right. So this is just again the review, and here's essentially the things I said about the EBPSs. And I don't have to go over this all again, but just remembering that this is a discoverable system, and we can name the palaces if we wanted to. We can, we can find different patterns within different palaces, which is to say, you know, EBPS one thrives with, multiples of 19. Its variants with multiples of 11, but other palaces such as EBPS three work better with multiples of 37. And so they're suitable for different kinds of particular magical system, right? So the 37s um, and 37 twice is 74, which is fairly close to 72. Of course, that's the Solomonic stuff. Um, and yeah, so different systems are different EBPSs are suited to different magical systems and resonances. And so we had this well, the greater Aberkey, but we really had this list of EBPSs um, in ranges. And remember, we kind of mapped it all out. And the important things here were the serial number, the order. So they each have a number, which is an address, and the brackets, which is the beginning and end, the beginning and ending emerps, and then this house grid. This house grid becomes more and more important because the house grid is essentially if you want to in a sense, because all EBPSs are divisible more or less by, well, they're all divisible by 18 and then plus one, right? So, sorry, minus one. Is it? No, 18 plus one. So every eBPS span is a multiple of 18 plus one. So, um, in other words, they have units of 18 kind of throughout. Um, but they share borders. So they're gridded. And what that lets us do is take really big eBPSs and actually just see them as relatively small. And that's pretty important. It helps us navigate internal to a given eBPS, particularly if you have a huge one, like well, in these two ranges, none of them are really huge, but like the biggest one in range two is 44. So it's a 44 by 44 by 44 cube. Well, you can give coordinates to where it would be, a layer, layer column row type coordinates that wouldn't be larger than 444. So that's a really good way of creating an internal coordinate on a slightly higher scale than the actual cell by cell by cell, and because if you locate the grid cube, and then it's just basically a 19 by 19 by 19, right? Um, so that's one of the things you can do. Um, and here's the big list. So here's the range threes, and of course there's way more of them than there were of the range twos. Just as there were way more range twos than the range ones, and so on. They multiply because there's more numbers, and the more digits there are in the brackets, you add a digit, and all of a sudden you're dealing with a much higher range of numbers. So you're going to have a lot more eBPSs. And we, for our purposes, are really just going out to 120, which is the first three ranges. It's not necessary to go further than that. Perhaps one day, you know, this knowledge will give us the tools to extend beyond that, but it doesn't seem really particularly necessary. And so I will be adding a number to this column, right? We've got the grid, the uh, sorry, the house grid, um, and it sounds like house band, right? But I mean it like the like a house, because it's it's each one of these cubes is sort of a mental house. And this makes it much easier to go in and occupy those spaces and fill them with furniture. Um, and okay, so then we moved on. So that was kind of the UKI, right, with all these resonances and stuff. And then the UMI was using forgetting about resonances altogether and just using them as frames to compare things in size to one another. And we know that we can multiply the scale of a so if we have a 19 by 19 by 19 cube, we can treat every subcube as a 19 by 19 by 19 cube, and we can zoom in infinitely and zoom out infinitely, and therein becomes the key. The interesting thing here is that you wouldn't have to zoom in infinitely or out infinitely, because pretty soon you'd come to the borders of the observable, particularly if you were trying to visualize a thing, a real thing. If you zoomed in infinitely, um, a certain amount of times, you would go beyond the Planck length, and it would no longer it would no longer be meaningful. And similarly, if you zoomed out a given number of times, um, you'd go beyond the scale of the universe itself. And again, it would become meaningless. So the universe, in a sense, occupies a very small range of the infinite ladder of scale for any given eBPS, and you can do it with eBPS one. You can do it with any one of them, and they'll handle it slightly differently, and that's interesting because there's a way in which the UMI has a kind of unique a unique number, which is more empirical, if you will, to lend to the eBPSs, and we'll talk about that. So we're mostly using eBPS one. I often use DPS one. Remember, the derivative palatial systems are variants of an eBPS. Usually, an eBPS has um, um, several of them, and they're just different ways of juggling the prime numbers in the constitution of the system, so that you can make them smaller or larger in very specific ways. The only thing is that the house grid does not get preserved. So the DPSs don't have the house grid, so they're not as central, but sometimes it's actually more useful to use them to set up a particular resonance pattern. Um, so we'll see. We'll see about that. But we're going to mostly be dealing with eBPS one when we do this stuff here. And here's the stuff we went over, where we're just mapping essentially the solar system. We had a map of some small objects about an inch, and then this is the solar system, and you can see what's happened is essentially I've scaled out. And sometimes I do this thing where I'll have a so let's say you have eBPS one as your main frame, and you want to scale out. You don't have to scale up by a factor of 19. You can actually scale it out by any eBPS. So I could scale it out by a factor of 55 if I wanted to, or a factor of 400 and whatever, 444, which is another eBPS number. You can do that. It's kind of a more sophisticated set of moves, and you can scale them out by DPSs as well. That just makes it a little bit more complex. So I don't want to overburden you. I want you to have the idea that you can just basically scale in and out of a given EBPS or DPS frame. And generally speaking, we would use the same number to scale up and down rather than hybridizing that. But it is doable. And it can produce some interesting results, many of which I'm sure I don't know yet. So we've got here this map of the this is the Earth. This is the Earth to Alpha Centauri, and puts Procyon slightly out of the grid. But of course, this is in a bigger 19 by 19, so we can just make this map happen. This is very flat, top down, and we're going to see how we might be able to flesh that out. But the last thing that we came to was what I labeled the metamagic ladder in the previous class, but I'm really calling the uniladder. Um, I have decided this unilaterally. But the uniladder is a way of, so I mean, just basically universal ladder. It's a scale ladder. So if you are starting here at um, a cube is 1 light year in distance, you're making that assumption. This is point 0. And if you scale up by 19, you keep doing this, you'll eventually get all the way up to the size of the observable universe. So this is yeah, 16,983,563,041 light years. So that is bigger than the size of the known universe, which is about 15 billion light years across. So you can imagine one cube, it's got the whole universe in it. And if you subdivide, 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 at certain levels of this ladder, you can say, okay, well, if I subdivide, um, you know, 6 times, then the Milky Way galaxy will be right smack dab in the middle. And if I subdivide, down to 9, you'll have the light year. If I subdivide all the way down to 12 from this universal picture, then we'll get the inner solar system and so forth. And then you keep going, and then um, at 21, you'll find the human body. And this is actually kind of objective. And what I found is that it kind of it doesn't. I keep finding I kept trying to start from different measurements. So I started from the measurement of the Laniakea supercluster. I started from the measurement of of a light year. I started from the measurement of the diameter of the sun, and it still ends up giving you pretty much the same information, which is that there's 50 rungs in the ladder, and from the size of the universe to a Planck length, and there are we show up around 21. That's a human body is. So what do we have this? You have to kind of jump from units because we're obviously not going to use astronomical units to describe a living room, right? So we're going to talk about that in terms of meters. Um, and so we have to convert, and astronomers do this anyways. They call this the ladder of measurements. And they convert from meters to kilometers to astronomical units to parsecs to kiloparsecs to light years and so forth. And so they do jump up and down this ladder. And similarly, there's a ladder going down into the very, very small, right? For the millimeters, nanometers, atometers, down to the Planck length, which is the smallest measurable length in the in the universe. And it's actually smaller in relation to the human body than the human body is to the entire universe. It's kind of staggering. Um, okay, so yeah, and here we have these numbers again that I showed us. This is just basically this one is organized by size. So I don't think I showed this before. This is a span size chart. So there's 60 span sizes. So this is not the EBPSs in order. This is from smallest to largest. And so you can see that there are some unique span sizes. For example, only EBPS 3 has a span size of 37, and that's a 2 by 2 cube. If you want to put it in the house grid. There's a lot of them have a span size of 181. There's like, a whole ton of them here, but like span size 60, there's only one EBPS. So this is so span size, yeah, sorry, 8533. This is massive, right? So this is the biggest one, and that's a house grid of 474. So that's just huge. But yeah, there's only one. And so that's some interesting stuff. Now, what does this mean for the the uniladder? So what I'm going to do is I'm going to stop the recording and we're going to have a look at another file, and we're going to look at basically the file I sent you with this class, or you've received with this class, and we'll talk about that. So we're going to stop the recording now.